Okay, let's say we have some number, like 2,300. And let's try writing it in a slightly different way. So one thing I could do is, since this ends in some zeros, is I could write this as 230 times 10. And that's true, because multiplying by 10 adds a 0. Or I could write it as 23 times 10 times 10. Or even 2.3 times 10 times 10 times 10. Now, you might wonder why I did this. It might seem excessive. After all, this might look a little more complicated than this. But if we have numbers with a whole bunch of zeros, it's actually sort of kind of hard for us to keep track at first glance of how many zeros there are. It gives us a better idea of the actual size of the number if we see 2.3 times 10 to the third power. So this is actually quite useful for us to do, rather than to try to scan a whole bunch of zeros and trying to decide which number might be bigger than which number. For example, I immediately know that 2.3 times 10 cubed is going to be, say, bigger than 2.1 times 10 cubed, without counting up the zeros. There are a lot of other advantages as well. Let's practice putting another number into this notation. So let's try maybe 725,000,000. So 7,250,000. Okay? Now, what happened here? Well, I could think about this as having a decimal point right there, like a 0.0. And each time I moved the decimal point to the left, I added a 10. And again, added a 10. Well, multiplied by a 10, and multiplied by another 10. So we ended up with 3 tens when we moved the decimal place 3 steps to the left. So if I start with a decimal here, I might want to move it 1, 2, 3, 4, 5, 6, and I get 7.25 times 10 to the 6th, and we just put this number into what we might call scientific notation.